Factorising and solving quadratics with Tutor. Here are the beginner questions, some of the easier questions that you're likely to find on this topic. A quadratic equation is a polynomial equation in the form ax squared plus bx plus c equals 0, where a, b and c are constants, x is the variable, and the highest power of x is 2, hence the name quadratic. Factorising is the process of breaking down a quadratic into the product of two factors, often two binomials. For the first question, notice we have the ax squared part of the quadratic alongside the bx part of the quadratic, but we don't actually have the plus c constant at the end. This type of quadratic is a special case that doesn't appear as often as the rest. This can be solved by first factorising into a single bracket. The highest common factor of 2x squared and 8x will be 2x, and then inside my single bracket, what do I have to multiply 2x by to give me 2x squared? And that would be x. And then what do I need to multiply 2x by to give me negative 8x? And that would be negative 4. Now I can move on to the second part of the question, which involves solving the quadratic equation. Notice we have 2x bracket x minus 4. This means that we're multiplying 2x by the bracket. If I do something multiplied by something else and I end up with an answer of 0, the only way of achieving 0 would be if one of the things I multiplied by was equal to 0. Hence, we'll end up with two solutions in this case, where 2x could be equal to 0, therefore x would be equal to 0, and secondly, where x minus 4 is equal to 0, I can add 4 to both sides, and therefore x would be equal to 4. The shortcut being, if you have a coefficient of x outside of a single bracket, x equals 0 will always be one of your solutions. And then inside the bracket, as long as it's in the format of x plus or minus something, we can just write down the number and switch the sign to say that a solution would be positive 4 instead of the negative 4 that's inside the bracket. For the second question, we need to solve something which is more in the typical format of a quadratic, where we have t squared minus 4t minus 12 equals 0. Notice how the question tells us to solve and doesn't explicitly say factorise and solve. We need to recognise that to solve this, factorising would be helpful and is typically something that we would be able to do on a non-calculator paper. I have a full video on factorising quadratic expressions where I go into more detail about how to do this, and that video is linked in the description below. But for the benefit of this video in terms of factorising and solving, I won't be going into as much detail on the factorising parts of the question. If you need to, you can go ahead and watch that video first before coming back to complete the solving parts of these questions. Quadratics in this form will typically factorise into double brackets, where I'm looking for numbers that multiply to give me negative 12 and add to give me negative 4. Those factors of negative 12 that add to give me negative 4 will be negative 6 and positive 2. If something has been multiplied by something to give me 0, then either one of these brackets must have been equal to 0. If t minus 6 was equal to 0, I can add 6 to both sides to give me a solution for t which is 6. And if t plus 2 is equal to 0, I can subtract 2 from both sides to give me another solution for t of negative 2. On to the intermediate question, with a slight increase in difficulty. We're being asked to solve by factorising, but we could just be asked to solve the quadratic equation instead. This time, I have a coefficient of b squared greater than 1. The AC method will be useful to help me factorise this quadratic. Start by multiplying a by c to give me positive 12, and I'm looking for factors of 12 that will add to give me the negative 13 in the middle. Once I've found these, I can rewrite the quadratic to b squared and split up the negative 13b term using these two factors, which would be negative 1b and negative 12b. Notice how these two terms add to give you negative 13b. And then when you multiply negative 1 by negative 12, we'll get the positive 12 here that we started with. Once you've successfully split into two terms, you can split the four terms in half to have 2 on the left-hand side, 2 on the right-hand side, before factorising each side into a single bracket. The highest common factor of 2b squared and negative 1b is b, and I would need to multiply this by 2b to give me 2b squared, and negative 1 to give me negative 1b. If you've done this correctly, the bracket that you have on the left hand side should be equal to the bracket that you have on the right hand side. This actually helps you to then factorise the one on the right correctly, since I'm now just looking at what I need to multiply 2b by to give me negative 12b, and this should be the same to multiply to get me from negative 1 to positive 6, which would correctly work for both if I used negative 6 as a factor. Once in this form, you can write as your two binomials or your two double brackets. One of the brackets is made up by what you've had in each of the brackets on the left and right hand side, 2b minus 1, and the other bracket is made up by the factors that you have outside of the single brackets, b minus 6. To solve, I'm looking for when 2b minus 1 is equal to 0. Therefore, I can add 1 to both sides to give me 2b is equal to 1, and then divide by 2 on both sides to give me b is equal to 1 over 2, or a half. And my other solution will be when b minus 6 is equal to 0. So adding 6 to both sides will give me my second solution for b, which is 6. On to the advanced question, one of the trickier questions that you're likely to find on this topic. To solve this equation, I'll have to get a quadratic equation in the form where it's equal to 0. So I can rearrange this equation. Subtracting 2t squared from both sides will give me 6t squared. Subtracting 2t from both sides will give me negative 13t. And then adding 13 to both sides is positive 6. Therefore, this can be rearranged to give me the quadratic equation of 6t squared minus 13t plus 6 is equal to 0. Since I have a coefficient of t squared greater than 1, I can use the AC method to help me factorise the quadratic. A multiplied by c is positive 36, and numbers that multiply to give me positive 36 add to give me negative 13 are negative 4t and negative 9t. I can split this in half before factorising the left hand side and the right hand side into single brackets. The highest common factor of 6t squared and negative 4t is 2t, and 2t multiplied by 3t will give me 6t squared, and 2t multiplied by negative 2 will give me negative 4t. Assuming I've done this correctly, my bracket of 3t minus 2 should be the same on the right hand side. I can multiply 3t by negative 3 to give me negative 9t, and I can see that this also works when I do negative 3 multiplied by negative 2, which would give me the positive 6. Therefore, one of my binomials is 3t minus 2, and the other one is 2t take away 3. If 3t minus 2 equals 0, then 3t would be equal to 2, and dividing by 3 would give me a solution for t, which would be 2 over 3. Secondly, if 2t minus 3 was equal to 0, then adding 3 to both sides would give me 2t is equal to 3, before dividing through by 2, and giving me a second solution for t, which would be 3 over 2. Here's a question that I've completed earlier. It appears as though I've made some mistakes. Pause the video and see if you can spot what they are before writing some corrections in the comments below.
Thanks for watching. If you found that video useful, don't forget to hit the like button and leave a comment. If you're struggling with topics or finding maths difficult, subscribe and turn on notifications to receive regular updates about new video tutorials and other useful content. You can visit and follow all of my socials by clicking the links in the description below.